In this session, we have, I call it the researcher or the legendary researcher on the alternate natural rubber, Dr. Katrina Cornish. She is currently a research director at the Ohio State University in USA. We'll be discussing about what's happening in USA about the alternate natural rubber options, what opportunities and challenges. And let me brief you about Dr. Katrina first, about her background. She is the leading US scientific expert and is internationally recognized as principal authority on alternative natural rubber production properties and products, and also on the natural rubber biosynthesis in general. Her inventions at the US Department of Agriculture were licensed by ULEX and formed the foundation of US domestic industry. She led the Department of Agriculture development of domestic natural rubber and rubber latex sources for more than 15 years. And also, she was also senior vice president of the at R&D at the ULEX. Currently, she is a research director at the Ohio State University, and she has more than 150 publications and many patents, and of which 120 publications are focused on the rubber biosynthesis and production. She received a number of awards. I have a long list of awards, but I can tell you, Dr. Katrina Cornish is the person we want to know about alternate natural rubber. She is the person who knows ins and outs of the various options of alternate natural rubber. Before I invite her, I have prepared a short presentation about her. Let me show you all about her profile, and also some additional information on her work as well. Okay, that's the short presentation on her work activities at the Ohio State University. So let's invite Dr. Katrina Cornish. Dr. Katrina, please come forward. Can you unmute yourself, please?
Can you hear me now?
Yes, very good. Hello, ma'am. How are you?
Oh, fine, thank you. Thank you very much for inviting me to this.
Well, actually, it's a pleasure to have you. And as I'm very much familiar that your extensive research work in 30 plus years, you are not only a researcher but also an entrepreneur, advising in many companies. I wonder how you manage your time.
Yes, what time? No, that's very true. I have actually had to let one or two of my startup companies go into abeyance because I don't have enough time to do them all. But Energene is my main company. That is the Wayuli latex production company in the States. Also, everybody open for investment. We raise fundraising at this time. And then American Sustainable Rubber is the hydroponic dandelion company in the States. I'd be happy to put anybody in touch with them if they are interested. There's quite a lot of different things there, but you know, I have got two sons through school. There's a dog in the background, but I do have actually over 300 publications now. So it does become, you know, you work hard. What can I say? You have to believe in what you're doing. You know, I am really alternative natural rubber is really important because we need biological diversity and we need geographical diversity to meet increasing demands. You know, the amount of rubber that Africa is going to need, for example, Havea is going to have a tremendous difficulty in meeting a doubling of demand, for example.
Well, let's check with you. Now, you've been a research director of the Program of Excellence in Natural Rubber Alternatives at the Ohio Agriculture Research and Development Center at the Ohio State University. Can you talk about what is this program about? It's been there, I think, since how many years is there?
Yes. This actually had been formed as a group before I even joined OSU, and I was basically brought in to, basically to run it, you know, in a sense. I'm the research director of that group. It's an industrial academic consortium. So it's set up a little bit like an NSF IUCRC, if you're familiar with those, but where the industrial partners contribute funds to help pre-patented research, you know, the stuff that they could all share before they take the information off and make their own proprietary tires, for example. And it has been largely supported by automotive and tire companies. So different members at different times, but we've had Ford, Goodyear, Cooper, and Bridgestone at one time or another. Goodyear has recently bought Cooper, so there's just Goodyear there at the moment, and American Sustainable Rubber is a Penra member. And then our academic partners are Oregon State University, Nebraska University, University of Akron, and OSU, the Ohio State University. And this is really useful because it allows us to have field trials in different places. So we do all the extraction in Worcester, but we develop the agronomic requirements and germplasm for other regions in the US. So that's so that's what we're doing. And then the group itself, we have a pilot plant. You saw some pictures that you showed in the slides, and it allows us to apply for the large grants because we have a processing plant and we have this consortium already in place. So that's been very valuable, but we're just finishing up a USDA Biomass Research and Development Initiative grant, which we got for $2 million, for example. And we have several other large grants in process that we're trying to get funding.
So this research program is only focusing on the alternate natural rubber, also any property improvements of the natural rubber itself?
So some of it, so certainly in my program, which we could say is in Penra or not, as you wish. All the dandelion work is definitely in Penra, but we've done a lot of work with natural rubber from Hervea and some synthetic rubber and Waiuli, where we have a lot more material to work with on sustainable processing aids, waste-derived reinforcing fillers as partial replacements of silica and carbon black, things like that. So we do a lot of work on 100% crop consumption, so we can try and make for green production systems, real biosystems with zero to landfills. What's the most profitable thing to do with all the different things that we produce as you do a process. So for example, with Waiuli, we take the leaves off first with the cryodefoliation process, but that's a valuable stream. You can extract a Canuba type wax from it if you wish, or you can just pelletize it and use it to power a biomass boiler at your processing plant, those sorts of things. But it all gets used.
Mm-hmm. So it's kind of zero waste policy type. Yeah.
Mm-hmm, mm-hmm.
Okay, let's get into the dandelion. I think you worked a lot on the dandelion. Okay, and so what is current situation about the dandelion research work, as well as whether it is commercialized on the process wise? What is status now?
Yeah, there's several different companies in the States working on the dandelion. Cultivat in St. Louis, Missouri, Farm Materials out of Cincinnati, Ohio, and American Sustainable Rubber, which is that was out of Chicago originally. It's recently been bought by Hemp, so I guess it's now out of Colorado. But the main issue in the field is weed control. We have got inbred lines now, thanks to one of our professors here, Jonathan Fresnedo, which are very useful. We have got gene editing technology and transformation technologies with the dandelion. We can even do chloroplast transformation. So the big issue is making it sturdy enough to compete in the field with weeds. We have good weeds here. And also to have a high enough yield so that the cost analyses look profitable. And so, for example, I know ASR, for example, has done cost analyses in a greenhouse system without adding the vertical parameter, so just single layer hydroponics, and that works if you also make use of the greens, so you could eat the greens. The real advantage in a hydroponic system is the multiple harvests that you can do. And it's also a very high throughput phenotyping system that we use to find those rare plants that have the much higher yields. Now, the highest I've ever seen in our collection here, unfortunately this was early on, and it's a dead plant, because we killed it before we found out how much it had, that was 22.8%. which would be very nice, whereas the lines that we're currently growing are about 8% on a dry weight basis. And the other interesting thing with the dandelion, if you're field growing it, most of the latex will be coagulated during the life of the plant. So it makes sense for that to be a solid rubber producer, which is what most most companies, apart from ASR, are looking at as a supplement for tire rubber, because its physical properties are very similar to Havea, whereas Wayuli, of course, is a softer, stretchier, different material than the other two, which do seem to be very similar.
And the dandelion, anybody's in farmers also accepting to grow? And what situation farmers?
Yeah, it's mostly on the experimental farm, but Farm Materials has commercial farms. They're planting this spring. They've come to an agreement with OSU for 1 million of the OSU seeds from one of the advanced populations. So that's actually waiting for pickup right now. So, and then with Wayuli, of course, we have, Energene has 150 million seeds of advanced lines that have 9 to 11%. So that we're ready to go on that as well. At the moment, the only public source, if you like, source of seed is OSU.
Okay.
You could get very small amounts from the Germplasm Center at USDA, which is where our stuff started. Their collection in 2008, I think, from Kazakhstan, Uzbekistan region. That's where all our population begins from, and we have a Sino-Russo collection as well.
So the seeds are exporting to other countries as well?
We've sent small amounts to other countries. At the moment, we're doing mostly in the US. If you send large quantities, it's possible under the appropriate agreements, but you would need to have your phytosanitary certificates in place and that sort of thing. So that the last thing you want is to, say, ship some to India. And there's been quite a lot of interest in India for Wayuli in the northern region there, where it's dry, But you don't let any of your seeds sit on a dock for 3 months in the heat or something while the customs are trying to work out how to let it go to the recipient. So you do need to be a bit careful about shipping stuff.
So when you compare with this dandelion and and Ulay, and which one is a better alternative? Okay, you mentioned, of course, dandelion is more solid rubber, and the Ulay is on the liquid side more. Okay, but in terms of the properties, can you talk about the properties and the strengths and?
Yeah, well, as I say, the dandelion rubber is pretty similar to like a TSR20. It's very similar sort of material. And the hydroponic dandelion might end up being a source of latex. So don't get me wrong. It's just if it's field grown, you're growing it as an annual plant, then it's the solid rubber. We are looking at the latex, so of course, see whether it will make a good glove. There is cross-reactivity with the latex allergy proteins in Havea. Again, it's quite a safe material provided you have proper manufacturing processes in your glove manufacturing. So it's not something to exclude. But Wayuli has different properties. So my favorite is Wayuli. I've worked on it the longest. I've only really intensively worked on dandelion for the last 11 years or so since I've been at OSU. Whereas I've had a whole career on the Wayuli because it's such a lovely elastomeric material for latex. It's thin. You can make very thin films that are very strong. It stretches more. For example, you can make an 11-inch balloon on a 9-inch former, for example. And it has other really interesting properties that the others don't have. So from a basic research point of view, if you freeze fracture rubber particles, the insides of Wayuli rubber particles still stretch in liquid nitrogen. Well, no other polymer I know does that. So we'd still very much like to get to the root of that cause. And then the other thing that's really good with Wayuli is it's got a higher polymer-filler interaction than the others because it's basically a linear molecule, not a branched molecule. So I think that makes that more intimate interaction between the polymer and the filler. And that's why we're able to develop this radiation attenuation natural medical examination glove. So it's not a personal protective equipment. It's actually a medical one, and so you could not have to double glove, which the FDA wants our healthcare workers to do. Put one glove on for disease and one glove on for radiation protection if you're using, say, C-arm procedure. with a Wayuli glove of that type, you can have just one glove doing both jobs. So we hope to get that through FDA next year. And then of course, we're also working with the greater group on standards. There was a question to Michelle earlier about standards. And although we do have 1076, which is D1076, which is the latex standard, there are different categories in that, so that you can look at your latex and see which one it fits and then claim that. But we're also looking now at, will it be possible to generate like standard, like SMR grades, technically specified grades of alternative rubbers. But the groups that are working on that, there's working groups for both Dandelion and Wayuli. But it seems like the most important thing to start with is to come up with a standard quantification method. So how much rubber does your germplasm have, for example, or how much rubber does your process get out, so that we can try and get that to apples. Whereas at the moment, lots of different methods are being used. So somebody says, well, I use this method, my plants have this much. Somebody else uses a different method and say, I disagree, your plants don't have that much, or they have more, that sort of thing. So certainly ASTM is certainly interested in developing those standards. And we're doing what we can to help them, of course, because we've got the materials and have experience with ASTM for a long time.
Even the heavier plantations also, I think, as you know very well, is affected by the climate change, okay, and also the diseases, number of other challenging issues, weather conditions. We have floods, so we can't, get a source of. Do you think these alternate natural rubber, whether Dandelion or Ulay, can plant in, conditions like in Asian or in African, where heavier is popular? Is it possible? It can be complement, yeah.
I don't think they're going to share the same region. Michel Dorger showed the map he took from one of my presentations. I think we have, Havere is tropical. Our two species are not tropical. So I think it would be very difficult to do it. But Wayuli is semi-arid. It comes from the Chihuahuan Desert. And this is really important now. I think farmer resistance to growing these alternatives in the southwestern region of the United States is taking a huge new look at it. I think resistance is going away because in this last year, both California and Arizona, who've been under a decades-long drought, have finally reduced the amount of water they are allowing their farmers. And it's been cut by 40%, which is a lot. Now, Wayuli is very happy on 60% of what they're used to using, but a lot of their crops would not be able to be grown now with that lower amount of water. And so I think that gives Wayuli a huge boost in the southwestern United States, which runs anywhere from California all the way over to West Texas. Now, Dandelion does need water, but that can be grown in snowy regions, so Northern Europe, Canada, Northern US. It comes from, Kazakhstan, Uzbekistan, where they have hard winters. So Wayuli can't grow under snow. It can take some snow. It does have a little bit of cold tolerance and frost tolerance, but if it's buried in the snow for a protracted period, it will die. Whereas Dandelion is quite happy sitting under the snow for all winter if you are growing it, if you are doing an overwintering crop. And then Dandelion too can be grown in the southern states as a winter crop. So you have it grown as sort of a regular annual in the northern states, but a winter crop in the southern states. And then of course there's the hydroponic option or aeroponic options for Dandelion, which aren't practical for Wayuli, which is a bush. But they both have the opportunity of multiple harvests from the same plants. So Wayuli, you cut the tops off, regrow it, cut the tops off, regrow it. So after your initial harvest, which depending on your planting date would be 18 months to 2 years, after that, each plant can be harvested again pretty much every year. So, and it's not dependent on a season for harvest. So you can harvest any day of the year, which is very nice in terms of reducing capex costs. And your process can be running all year round. So it's not like tomato peels, you know, where the tomato processing all takes place in the fall in the US, and then the plant is shut down for the rest of till the next autumn. You know, a Wayuli latex extraction plant goes all year round.
How about the yield rates? Yield rates of the rubber from dandelion as well. You are specialized on the biosynthesis. Are you working on increasing the yields or any special genome technology or anything?
Yes, we are. We do that in both species, but dandelion, being a little herbaceous plant, is a very nice molecular biology sort of system. So there we have a number of different approaches for diverting carbon to rubber. So yeah, so we use CRISPR gene editing, for example. We've got a bunch of plants we're growing up now. They've made it out of tissue culture and are now in the greenhouse. And so hopefully this, in a few months when they're big enough, we can actually see whether the gene editing we did to increase yield has worked. We did actually take a similar approach a few years ago, but we only edited one site in the gene, and this time we did two because we lost it during the breeding process. So hopefully this time we won't.
So there is progress is happening there in yields.
Yes, yes. Yes, and it's very hands dependent sort of work. So the amount of effort that goes on at any particular time depends on how much funding I have and how many students I have that can do that work. So we're at a bit of a low at the moment.
And like you go back to your companies now, look into your entrepreneurial activities. But before go to entrepreneurial, you work with Ulex for 10+ years, is it right? Yeah.
Well, I actually worked for Ulex for 6 years, but prior to that, Ulex were the licensee of the latex extraction process I invented at USDA. And then back in 2004, they asked me if would I please move over to the company, because their investors were saying if I didn't, they were going to pull the plug. They needed Ulex to have a stronger scientific basis. So I worked for them for first in Southern California for 3 years, and then got transferred over to Arizona for 3 years. And so so I learned a lot. That was very interesting. So the first 3 years it was being built for sale, but it didn't sell. And then after that, its efforts to convert to an operating company didn't go very well. And after I left in 2010 to join OSU, it's a couple of years after that, Ulex went under. They went bankrupt and sold everything off. Now I do think and that was Ulex Inc. Now, which I think there is a Ulex LLC still out there, but they're not producing Wayuli latex that I'm aware of.
But I think they did some good promotion on the Wayuli, in terms of the branding, the Wayuli applications wise in that period. Is it right?
Getting the 510K with FDA for the examination glove was very good. So yes. And other companies made many other things, you know, so a Foley catheter was successfully made with Wayuli, surgeon's gloves were made with Wayuli, all sorts of balloons, many tires, of course. Cooper Tire made 100% Wayuli tire just a very few years ago under a Birdie grant. So you can make anything out of Wayuli that you make out of any of the others, out of Hevea. So it's a very nice material. The different types of, going back to the quality question that you mentioned, if you do what I think Versalis and Bridgestone are now thinking of doing, is taking the solid rubber which you solvent extracted, so you now have solvent extracted rubber, and you turn that back into a latex, it won't be the same latex as Wayuli latex such as we extract, or that Michel Dorget extracts, or or Nokian or Weiss, any of these other companies, because those are the intact rubber particles. And I think, as everybody knows, the membrane components of a rubber particle become an integral part of the compound. And so they will change the properties of the rubber. So if you've done a solvent extraction, all those membrane components are gone. And you'll then have a stabilization medium, a detergent or something instead that forms a micelle, but it won't behave the same way as a natural, as the original latex would do. It's probably, this is just a prediction, it's probably end up behaving much more like a polyisoprene, you know, a synthetic polyisoprene than a natural latex.
You know, I wanted to get to know more about your company, Energy In.
Yes.
That's so. Can you give more details about this this company? I think you're talking about the funding opportunities also there. Mm-hmm. Yeah, please.
Yeah. So and it's pronounced Energene, so the Y is silent. We set this company up, I think it was 2013, to bring Wayuli latex back again after Ulex failed. And we developed new technologies at OSU, which are licensed to Energene exclusively. So we have a new, an issued patent that issued, I think, in 2018 on improved processing. Because one of the things was, having worked for Ulex, I could see where their build of the, at least in the demonstration plant, where their pain points were. So I could address those specifically. And so we have a new processing patent that's got a lot of legs on it yet. We also have some other related patents. We have germplasm patents, and also as a pending patent on the radiation, the Wayuli radiation attenuation glove. So we have, then we also have detailed business plans and financials, everything from upgrading the pilot plant to a continuous flow, it's batch, the pilot plant, of course, out to building a full-size biorefinery, and anything from a 5-year plan out to a 15-year plan, depending on what somebody wants to see. That includes all the costs in it. And once they get into production, it's a bit like when ethanol started. You know, getting the first ethanol plant up was a just horrendous effort, and I think the government had to really contribute to doing that. But after that, then they sprang up all over the place. And it's the same with an Energene biorefinery. As soon as we get the first one up, and it goes into production and it's making money, then you just go to the bank for the rest. But the US alone, if we do it at the scale that we're looking at just for self-sustainability, needs 600 of these, you know, because as it's fresh shrub processing for latex, you don't want a massive plant. You want fairly small ones, so that the transportation of your shrub or your roots, they don't have to go very far. So we're saying you want to be within a 25-mile radius of your processing plant, and then you go down the road, and then you have another processing plant to serve the next part of the next area of Wayuli. But it's a modular build, so very cookie cutter. You know, once you've made one, you can just copy it. If you have a high density of shrub in a particular area, you just put in effect 2 processing lines in instead of 1. You know, so it's very reproducible in that way. So,
is the government giving some support for you on this?
Well,
projects?
Not yet, but we're really working toward that. So, Energene got a conference grant from USDA. And we have finally had that meeting last year. It was stalled because of COVID, of course. But we had this hybrid meeting, and this was to try and pull together all the people that are interested in natural rubber and natural rubber supply security, which has been a real trial in the US. I've even heard of some American companies having to fly rubber in. So, you know, that certainly put the cost up for them. But anyway, so the US government is now working on trying to pull together an interagency program. So not just USDA, but USDA and DOE and the Department of Energy and the Department of Transportation and the National Institutes of Health, you know, just pull all of them together and say, we need natural rubber in the US. There's no sector of our economy is independent of a natural rubber supply. You know, we have to have it, and we don't have it. And most of it comes from Southeast Asia, which is the other side of the world. And you know, with the supply chain issues, you know, the enormous number of container ships just sitting off our ports, that even if some rubber was sent, it has still got to get it to the factory, you know. And so these are making certainly our military and homeland security people very nervous again. They finally noticed again, just a minute, you know, you mean we can't fight a war if we don't have any natural rubber, and we don't have any? This is so so I'm hoping that this time it will actually establish permanently. And if you know, if disease felled Hevea, which is possible, you know, this is a clonal tree. Just look how fast the leaf blights, you know, the Pesilotiopsis and Neophusicoccus spread in 2019 and 20. You know, Hevea could face a collapse. And if we have a significant amount, if we already have an industry, you could scale that very quickly. If you don't, it would be very much more painful. And then I did hear just last month that Thailand announced they had 40 acres of virus infection. And it's like, oh my goodness. And I was thinking, well, look how fast coronavirus spread. How fast is that Thailand leaf virus going to spread, you know? So I think that biological and geographical diversity are very much at the core of global natural rubber. You know, we should not rely just on one clonal species. It's just too dangerous for us all, I think.
You also involved in one other company called American Sustainable Rubber Company, is it right? You know, what
yes,
kind of activity?
Yeah, I'm a scientific advisor to them. They are they've licensed some technology from my OSU program. The core technology, though, is the hydroponic technology, and our university decided not to try and patent that. Though we do have one with CTTM, but they decided it would be too difficult to defend such a patent, so they didn't go for it. However, the company is based on the hydroponic dandelion as a highly productive rubber production system. And if there became a major problem with the US rubber supply, intensive vertical farming of rubber would be the fastest way to replace the rubber, or to make meaningful amounts, because there's lots of warehouses you could put things in. It's just how fast can you go? You could convert a bunch of the ones already there to make herbs and lettuces and things like that to a rubber production system. So I think now that type of system is more expensive farming method than growing it in the field. But you have a lot of other issues where it can be better. You know, you don't have to worry about escapes if you were doing gene-edited plants and things like that. So so that company, that one's also open for investment, guys. You know, all of these startups are all looking for investments.
Yeah.
So,
and how is it tire industry is doing? Any active research, actively involved in US tire industry in getting a local supply, you know, like alternate natural rubber? What kind of activities happening there?
Yeah, well, this is why Bridgestone has invested in Waiuli. They're going to loan it, but they have their bio-rubber pilot plant in Mesa and their research farm in Eloy, and then Goodyear has for some years supported Penra in the dandelion rubber. And the original premise of all of this is if we could produce, say, 10% of the US supply domestically in the country, that would have a significant impact on price volatility in the Hevea natural rubber market. You know, it would have a calming influence. But unfortunately, when you're working with the tire companies, they want it at a commodity price. And as Michelle said, you can't have it at a commodity price if you've only got 10 acres or 100 acres or even 1,000 acres and a pilot plant. It doesn't work that way. You have no economies of scale. You have to go in. I've said this for 35 years, really. So you have to be commercially viable in normal times, not just in emergencies. So that's where Waiuli, why alternative natural rubber in the States has not taken hold. They put a lot of money in whenever there's emergency, and then they take all the money away again when the emergency is over. You know, and so this doesn't work. So this is why when type 1 latex allergy hit, why I really put a lot of effort when I found that there was no cross reaction between Wayuli latex proteins and Hevea latex proteins, there was an opportunity for Wayuli latex that would be profitable in normal economic times. So get the crop established that way. And so, and you can make these specialty products with relatively small processing capacities and relatively small acreages. But you can't get to commodities until you've got at least, 10 processing plants and 100,000 acres at least, those sorts of scales. But you can't get there without going through the premium markets, or it's extraordinarily more difficult to get there. So
you did work on the bio-based fillers for applications in the rubber industry.
Yes,
like
yes.
Eggs, from eggs and those eggshells and stuff like that. And can you talk about what are status, what kind of bio-based fillers you develop as a researcher?
Yes.
Are they patented? Yeah.
Yeah, well, they're not actually patented, to my regret, because when we put a patent in, the patent office wanted to divide them up completely. So we put in several fillers and SBR, Hevea natural rubber and Wayuli natural rubber, and they wanted to then split them apart. So instead of having them all in one, you'd have, okay, eggshells in Wayuli, then you'd have eggshells in Hevea, and then you'd have eggshells in SBR, and all those being separate patents. Well, the cost was just completely prohibitive. It's impossible to do that. But however, the eggshell one, which is a really attractive material because it's produced every day of the year, so it's not like tomato peels, which is the other one we did a lot of work with. They're only produced in the autumn. But the eggshells, what we found was if you ground them to a micro scale, so small micro, you don't have to go all the way to nano. If you went all the way to nano, you could get a very good replacement in Wayuli, completely replace carbon black, but of course it's very expensive to grind to nano. So it's not very expensive to grind to micro. But we found that with a partial replacement of the reinforcing fillers, like carbon black or bifunctionalized silica, that you could get very good properties with partial replacements, even 60 or 70% replacement. And one of the things that's happening is quite apart from the interaction of the eggshell microstructure with the rubber polymers, those eggshells seem to act like tiny little ball mills in the mixer, so that they disperse the other filler better, because the fillers tend to aggregate because they like themselves more than they like the rubber. And with the eggshells in there, we got a better dispersion of the other filler in addition to a really good dispersion of the eggshell. Okay, so that one is actually available in 10 kilogram plus quantities. So it's being distributed by a company called Peloton Technologies. So if anybody wants to try the eggshell filler, I could put you in touch with Rob Yenny. And so that is actually on the low commercial availability scale. The other one that we worked on, which is very interesting filler, was from tomato peels, so processing tomatoes. These are made, both of these fillers, both of these materials, wastes, are produced in like 600,000 tons a year. So these are enough to make a meaningful difference in a filler market if you're doing a partial replacement. But they're only produced, as I said, one time a year. And they were lightweight filler. And they are also pretty attractive in a plastic, because they are basically a cutin and wax based, more polyester type of filler than the eggshells, which are. And I was surprised, I have to admit, Param. I thought when we first looked at the eggshells that it was just going to be a sustainable form of calcium carbonate. So stop mining it, just use the eggshells, But they actually did turn out to have some reinforcing properties that we weren't really expecting. But that was very nice to see.
Did you do any cost analysis of making of that filler in terms of collection? Because so many eggs are there, people eat every day, all over the world.
Yes,
right? Yes.
Absolutely. But we're working with major egg processing companies in the States. So I can't comment on the cost of doing it. That would have to be something you take up with Peloton Technologies, which is a distributor. But nonetheless, certainly in the more premium markets, we certainly had interest from sporting goods people about them, as well as from hoses and you know, so a number of different types of industries have been trialing the eggshell material.
Because I think most of the companies are also looking towards sustainable materials, you know, bio-based materials and applications, you know, in utilize. Even the tire companies are very much into, they're saying 90%, 100% sustainable materials in production of.
That's right. That's right.
Huge potential, yeah.
And that brings us to the processing aid that we developed, you know. So there's some companies, I know that Goodyear, for example, has released a tire or is distributing a tire that is using like a deresonated soybean oil-based processing aid instead of naphthenic oil. But we ran some trials using a low molecular weight rubber. It was actually Wayuli low molecular weight rubber that we made as a replacement for naphthenic oil, and it works beautifully. It works in SBR. And you don't get the same dilution of your mechanical properties that you get with a soybean oil or a naphthenic oil, because those are passive processing aids that are there to modify the viscosity so that you can mix in your materials better, your other additives better. But if you use a low molecular weight rubber, it looks like an oil, but it's an active part of the compound. And so that worked very well. And I know there are people, our companies, I can't remember the name off the top of the head, that make low molecular weight Havea rubber. And I think that might be a very good thing to try while you're waiting for enough Wayuli rubber to destroy some of it that way. But that was amazingly effective. That paper should be coming out in the next month or so.
You know,
Yeah, and from a sustainability point of view, I know at the moment there's only a little bit of movement between synthetic rubber and natural rubber, but natural rubber can be chemically modified and make it closer to some of the synthetic markets. So that's also something I would like to see the natural rubber industry do in terms of the sustainability. You know, you could epoxidize natural rubber. That gets you some of the oil resistance, solvent resistance that it doesn't naturally have. You know, things like that. You can methyl acrylate it. You could do all the basic rubber chemistries to the alternatives and to Havea rubber itself, which would allow you to, say, progressively encroach on the synthetic rubber markets.
Okay, Dr. Katrina, it's really nice to, you know, taking inputs on various things happening on the, you know, alternative natural rubber, and also get to know about your other research work on the bio-based fillers, you know, and the process aids. Finally, before I let you go, I'd like to ask you how you know, you've been 30 plus years and doing this research on the alternate natural rubber, and look back and now how you see the future of alternative natural rubber.
Well, the way I see the future hasn't really changed a lot from how I've always done. I've always, you know, as soon as I got into this field, I went, what, you know, we're dependent on tropical clonal rubber, you know, and it's like, you know, and I'm a plant biologist in background, original background, and it's like that's not a good thing. That is not a good thing. You know, if you look at any other agricultural crop output that we have, they all have backups. You know, if you think, okay, we grow crops for starch. Well, if the corn crop failed, you've got wheat, barley, and potatoes, you know, and hundreds of others, you know, oil seeds. You know, there's dozens of oil seed crops, you know. There's one rubber crop, you know, and it's grown as clones, you know, genetically identical clones. And in my lifetime, you know, we've seen the elm tree collapse, we've seen emerald ash, we've seen pine beetle, we've seen all of these non-clonal tree species collapse. So it's just to me, it just feels like Havea brasiliensis is this sort of ticking time bomb. And then when we had that major disease spread in 2019, I thought the rubber apocalypse might be upon us. Unfortunately, I think that hasn't happened this time. But you know, I think it's your salve is going to get into Southeast Asia one of these days, you know, and SALB's still fatal. You know, South American leaf blight, that's a fatal disease. So I just think that we have to have this biodiversity. Now, the future of it, certainly working in the States, you know, this is a tremendously reactive business community or economy, not a proactive one. Nobody wants to pay proactively for something that they'd rather have a huge disaster and then struggle like crazy for 5 years, rather than putting a bit, which should be far more expensive than doing it in advance. We know there's going to be a problem. Let's just get everything sorted so that when something bad happens, we're not in a terrible position. But it's very difficult to get the investment for people to say, you know, which is why we've really focused on these premium markets. Get the investment for the radiation attenuation glove, for example. That's far more doable than saying, tire companies, you're going to be in so much pain, you don't even know where you're coming from if you don't put a whole bunch of money in now, so we can get this thing scaled to where it's meaningful for tires. You know, you've got to go through these other ones first, and I think it's a more investable proposition. And we, you know, so I do think it's going to happen, and I do think we're going to see one of these multitude of startup companies pull in a major investment within the next 5 years, hopefully sooner than that, this year possibly, with the disrupted supply chains. And then once we see these commercial plants start going up, then the really important thing is to make sure they stay up and they form a basis of expansion. But it has to be economically viable in normal commercial times. So you might get it up because of what's happening at the moment in Ukraine or COVID, but you've got to make sure that your business plan is viable when things are back to normal, because otherwise it's all going to go away again. And I can't do it a fourth time. You know, I've done Wayuli twice and Dandelion once, but you know, I can't do it another time.
Right.
I am getting too old now to do it a fourth time.
I understand. I understand. Katrina, thank you very much. You know, it's really wonderful to having you in this program. It's a lot of learning, and you share a lot of insights. I'm hoping, and you know, people who are audience watching and viewing later on as well, you know, invest in alternate sources, you know, to sustain. I think this is, as you rightly mentioned, the word biodiversity. It's, you know, so. Yeah.
I think we could cover the world with rubber crops. We only need 3 to do that. You know, Hevea, Dandelion, Wayuli. You grow it everywhere.
Right. Once again.
Yeah. Okay.
Go on. You conclude. Yeah.
I was just going to say too, and going this route, of course, will use up a lot of carbon. You know, it will help. It's just a tiny blip on the huge challenge, but will be a very positive carbon footprint. You know, rubber's a terminal sink. You know, synthetic rubber has a horrible carbon footprint. You know, these will be much better. And the analysis suggests that that Wayuli and Dandelion will have about half the carbon footprint that Hevea does. So Hevea is better than the synthetics by far. So you know, these are all going in the right direction, because we have to tilt the whole CO2 accumulation parameter back, or our grandchildren aren't going to have a world to live in, are they? It's going to be worth it anyway. So anyway, I do think that those are very important things to consider as we move forward into the bioeconomy years.
Yes, for the future of our next generation. You know, we need to change our habits, you know. Rightly, you know, look for our generations to stay safe and, you know, having the proper resources, you know, to there for them. Yeah. Katrina, once again, thank you very much. Okay, and we catch up again, and look forward to welcome you in the future episodes. And I'll, you know, like to introduce those bio-based fillers and all whatever, you know, the work you are doing. Given this platform also to industry to understand as well. Yeah. Once again, thank you very much.
Thank you for having me.
Thanks a lot. Cheers.